Welcome. Thank you for tuning in to this presentation from the Choices Community of Practice. The Choices Community of Practice includes people whose work focuses on advancing obesity prevention, healthy eating, and active living, and want to learn more about how cost-effectiveness analysis can advance their efforts and address health equity. The goal of the Choices Project team is to support these efforts by providing tools, resources, and training opportunities. We hope you enjoy this presentation and find it informative. Thank you for joining us.
For this session on assessing the impact of strategies for the choices model, we have the following three objectives. First, by the end of this, you should be able to explain the importance of quantitative estimates for behavior and BMI change, to be able to describe how the quality of research evidence is determined by the choices team, and to describe how we use the strategy to health pathway to estimate a strategy's impact on population health. First, let's talk about effect estimates. When we're talking about the choices model, we want to be able to estimate what the impact of a childhood obesity prevention strategy would be if we used it in the population. In order to actually do that and put a number on the impact of the strategy on childhood obesity cases, we need to use quantitative estimates of the impact that a given strategy has on childhood obesity. So we don't do those studies ourselves. We don't come up with the estimates of the impact of a strategy on childhood obesity ourselves. We use estimates of different intervention effects from the published literature. So we pull from a large body of evidence, which I'll talk about in a minute, to try to search for strong, high-quality evidence of an intervention's impact on either a change in BMI or BMI Z-score for children. And if that's not available, we can also use evidence for impact on change in dietary intake, especially intake of kilocalories or intake of sugar-sweetened beverages, which we are able to then link back to changes in BMI, or changes in moderate to vigorous physical activity, which we can also link to BMI change, or changes in television viewing time, which we also are able to link back to changes in BMI. Ultimately, we're trying to loop our evidence back to an impact on changing obesity risk. So we can either look at BMI or we can look at these behaviors that we know are tied with obesity risk and that we can quantify. So how did we find these effect estimates for the Choices Project? Like I said, we didn't do the studies ourselves. We didn't come up with the evidence ourselves. We instead used a very large systematic review approach to find the relevant estimates. We did not do any new data collection. We really relied on a huge body of scholarship out there to find some really strong estimates for impact for a range of different strategies. So what's a systematic review? It's a formal process to review large bodies of scientific literature. You'll see lots of published systematic reviews out there on different topics. When there's been a lot of studies in one area, usually someone will kind of take it upon themselves to do this kind of process of very systematically reviewing the literature and making sure that all relevant studies are pulled in using sort of some search terms that you usually work on with an actual librarian to make sure that you don't miss potentially relevant literature, and usually using different search databases as well to make sure that you don't miss anything. The next sort of step in the systematic review is to have trained reviewers assess the quality of the studies that are pulled in. So in our case, we had 2 reviewers first kind of screen through everything to make sure to see what studies were actually relevant, because as you probably know from searching PubMed or Google Scholar or something like that, your first pass is going to pull in a lot of studies that really don't matter for what you're trying to look at. So we had folks first kind of slough out the ones that weren't really relevant to childhood obesity prevention, and then do a process where they assessed the quality of the studies that came in sort of under the search, and then summarize the evidence. So those are sort of the big steps that we had our team take as we were looking through the evidence. So for the choices systematic review, because we were looking at so many different strategies, we started out looking at 43 strategies total. We have pulled together for all of our systematic reviews 129,000 different studies that we've had to sort of sift through. Our team has then looked at the abstracts for 22,000 of those to see if they're relevant, and then we've gone and looked at the full article for 3,724. So we've actually had our really amazing team read through nearly 4,000 articles in search of the best effect estimates that we can find. And that has resulted in us actually pulling out 635 articles for fully pulling out data and summarizing it to be used in the model. So that's 0.05% of what we initially pulled in. So it's a very, very large process. It's a very onerous process, but it is what we have to do to find the best evidence out there, and makes us pretty confident that what we found is the most appropriate evidence we can be using for the model. So once we have those 635 studies at 0.05%, what information do we pull out? What we look at is the components of the strategy or the intervention. So are they comparable to the strategy that we're modeling? So say we want to look at an intervention to reduce the amounts of sugary beverages that are served in schools, and we are looking at a paper that describes an intervention that's somewhat related to sugary drinks, but they didn't quite do a reduction initiative in schools like the one that we're modeling. We wouldn't necessarily then say that we should be using this evidence for impact of effect to model our school reduction strategy for sugar sweetened beverages, because maybe there's a mismatch. Like, we want to have confidence that what we are using for an effect has been caused by the strategy components that we actually want to model. The other information that we pull out is information on the study design. Study design matters so much for whether we feel like we can trust an effect estimate. There are a lot of preliminary studies out there with weaker designs that may just not have very strong evidence for them. So we want to make sure that we have something that uses a very strong design, which I'll talk about in a little bit, in order to actually trust that we're using the right effect estimate. We also look in the study for information on how the study population was defined and who was actually reached by the intervention. So if we are trying to look for studies that show an impact for 2 to 5-year-olds because we're doing a childcare intervention, we would want to make sure very carefully that we see that the study population actually was 2 to 5-year-olds and wasn't, 9 to 12-year-olds or something like that, where the study population may not have been actually comparable, and we wouldn't be able to trust that the effect would be the same. We also look for that effect estimate, so we try to hone in on what that quantitative estimate was. So was it for example, a 0.14 unit decrease in BMI Z-score? Was it a 1-hour decrease in television watch per day, or an 8-ounce decrease in sugar sweetened beverage consumption? We want to find what that effect of the intervention actually was in a quantitative term. And then we do look to see if the paper included any information on costs, not just, dollar amounts that the authors estimated, but if they mention how many hours it took to do certain activities, sort of what are sort of the resources that the intervention required to be implemented, we pull out that information as well. So study design is something that is really critical in terms of determining whether we feel like an effect estimate from the literature is valid. What we do is we prioritize effect estimates that are from strong designs that provide the opportunity for strong causal inference. And traditionally, um, when we look at the methods that are used for determining the impact of an intervention on obesity or any outcome really, what we want to do is stick to experimental studies. So this includes randomized controlled trials, which is the gold standard, or quasi-experiments where maybe the assignment of the intervention wasn't random, but was still sort of a situation where you had some people who got a treatment and some people who didn't, so you can compare them. Or natural experiments, which we actually use quite a lot, where you might have a situation where a policy changed in one town but not another, or in one school or not another, and the schools are fairly comparable or the towns are fairly comparable, and you can actually see over time how the policy change or the program change actually impacted the two different schools or towns differently. So that's what we're really looking for, is something where somebody changed something within the study and we're able to see from before to after the change what happened in groups that got the change versus didn't get the change, so we can really isolate the impact of that strategy. In some cases, we have used also longitudinal studies that use a change in change design. This is also sometimes referred to as a diff in diff, or difference in difference, or within subjects, or fixed effects regression model. But these studies are really useful sometimes because they sort of simulate an experiment by looking at what happens when someone changes their exposure to something over time and comparing what they looked like on an outcome before they got the exposure and then what they looked like after. This is really useful because it's just looking within a given study participant, so it's the same person and you're looking to see what happens after something has changed within them, instead of comparing two people, one of whom just happens to have an exposure and one of whom doesn't. And you then introduce a whole range of problems where you don't know whether the outcome that you're seeing is different because they were exposed, or whether it's because of the fact that they're just two different people who have a whole host of differences between them. So the change in change longitudinal study can be helpful, but it is still not as strong a design as an experimental design. Now, cross-sectional studies, which are very highly prevalent in the literature, and cross-sectional studies are useful in a lot of cases. I've certainly done several cross-sectional studies. Sometimes you need to do them in order to generate hypotheses, or to look at what's happening in a population, or to look at the prevalence of something. But they do not tend to produce valid effect estimates, only associations, because we just don't know whether the outcome happened before the exposure happened. We don't know, we can't really appropriately control for confounding. There's a lot of problems with using a cross-sectional study association as a causal estimate. So we do not use these for effect estimates for choices, just full stop. And this actually has sort of is a big source of kind of limiting a lot of the literature that's out there, because we are not able to really estimate the impact of a lot of strategies that just only have cross-sectional data on them. But we do this because, again, and we'll talk a little bit more too about sort of the pitfalls of cross-sectional studies, but they really can give us kind of the wrong answer when it comes to trying to estimate the impact of something. So to walk through how how this can matter as an example of why study design matters. Let's take sugary drinks and BMI. So we know that sugary drinks cause weight gain. They cause excess weight gain. Drinking lots of sugary drinks, sugar sweetened beverages, soda, lemonade, all that jazz, cause us to gain extra weight on average. So if though you were doing a cross-sectional study of the link between sugary drink consumption and BMI, you would find that sugary drinks are not associated with higher BMI. And in fact, several NHANES studies using cross-sectional data with NHANES or other very large data sets have found exactly that, that if you look at sugary drink consumption BMI, there's just nothing there. But if you use a change in change model, so that's that longitudinal difference in difference model, you do find that sugary drinks are associated with a significantly higher BMI, because what you're doing there is looking at whether someone increases their sugary drink consumption over time and then sees any change in their BMI, and you will find an association that way. The gold standard using a randomized controlled trial, you do find even clearer that for each 8-ounce serving of sugary drinks that are given to a child or that are as part of an intervention, cause a significant gain in BMI, so that translated to about an extra increase of about 1 kilogram in children. Another thing that we look very carefully at is measure quality. So there are a lot of measures out there for things like BMI or for dietary intake or for physical activity that are a little bit prone to error. And the problem with that is that when you use a measure of an outcome or an exposure that isn't very precise, it introduces error into your effect estimates. So you can end up with the wrong conclusions. So if you have something where you are observing someone's physical activity and kind of writing it down on a notepad, you might end up kind of over or underestimating how physically active they actually are, versus using an accelerometer, which is a super objective measure of how much a child is actually moving. Same with, like, if someone is reporting their weight and height, that is not going to be as accurate as measuring weight and height on an actual scale and stadiometer. So we stick to these objective measures. The reason we do that, again, is because that's another way that can introduce sort of a weakness into the effect estimate, and we just don't want to do that. We don't want to use something where we don't really quite trust the results. So we always also stick to studies that use these objective measures, like height and weight that's clinically measured, dietary intake that's done through plate waist or other strong dietary assessments, and accelerometer measured physical activity. Another thing we consider is whether there's a baseline and a follow-up measure. We don't like to use studies that use just a follow-up measure, because you don't know whether there might have been, even in an experimental study, whether there might have been differences at baseline between an exposed and an unexposed group, or an intervention and control group, that could actually produce like a smaller effect if you're only looking at the follow-up measure. So we want to know how things changed, not just how they ended up. We also look at the timing of the measurement. So we want to give a reasonable amount of time to see a BMI change after an intervention or a strategy has been implemented, usually 6 months for BMI change in children. If it's been only, a 3-month follow-up or something like that, that's really not enough time to see changes, generally speaking. So we like to have a good amount of time before you actually have that follow-up assessment taken, so we know for sure that the strategy had an effect. And again, it takes time to change BMI. So Kevin Hall's team has estimated that in children, the half time to full change is for BMI is 6 months, and the full time to change is a whole year. So it really does just take a long time if we're going to do sort of an activity that changes a child's obesity risk. It's going to take a while to really see the full effect. So we want to give those studies enough time to actually show what's happening. The strategy to health pathway is what we use to sort of pull all of our evidence together and find out what type of evidence do we need to look for, what is the strategy going to look like, what behaviors do we think are impacted, and what kind of chain reaction has to happen to impact BMI. When we make these strategy to health pathways, sort of each link in the model is representing a place where we have evidence for impact. So I'll walk you through some examples. So here's sort of an overall one. We start over here on the left with a policy or a program or another kind of strategy implementation that we think we're gonna put into place. We then sort of assume that what's going to happen next is some kind of behavioral change in the short term. So it might change our purchases of sugary drinks, or it might change the types of foods that are offered in childcare centers, for example. We then would see sort of an intermediate behavioral change that's going to impact BMI, like a change in energy balance. So you're either going to see lower calorie intake or higher energy expenditure that's going to then have an impact on BMI. Then that's going to lead to that anthropometric change, so looking for a change in BMI, BMI Z-score, or weight. And that is ultimately then going to have impacts on obesity, healthcare costs, and mortality, which is what we end up modeling in the choices microsimulation model. Ideally, we look for evidence that links a strategy directly to BMI. So that's sort of our best case scenario, that we don't have to worry about what's going on in those interim pathways. We just want to see, okay, we implemented this policy, we implemented this program in childcare or in after-school programs, and this was what we saw happened to children's BMI from before to after the intervention was implemented. For the intervention versus the control group. Ideally, that's what we're going to see. The next best case is when we have, if we can't find something with evidence for direct effects on BMI, we look for evidence for an impact on energy balance. So something that shows us that there is a direct link between the policy or program and then a change in moderate to vigorous physical activity, or a change in calorie intake, or a change in sugary drink intake. Then we link that to BMI later, and we have a sort of set of standard studies that we use that and standard quantitative estimates that we use that link the change in energy balance to the change in BMI. So these are the studies that we use. If we have evidence for an increase in moderate to vigorous physical activity, we use a study published by Creamer et al. That shows a direct link between increases in moderate to vigorous physical activity and decreases in BMI for children. And so we're able to quantify then changes in moderate to vigorous physical activity based on this estimate. For sugar-sweetened beverages, we utilize the estimate of a change in ounces of sugar-sweetened beverages consumed to a change in BMI from a randomized controlled trial led by De Ruyter et al. In 2012. For an impact of changes in overall calorie intake, we use a model that was developed by Kevin Hall in 2011, but we do this somewhat rarely now. We really try to focus more on the physical activity in sugar-sweetened beverages, in particular if we can't get evidence for an impact on BMI. And then for an impact of a change in television time, we use evidence from 2 randomized controlled trials that looked at reducing TV time in children and then changes in BMI, and actually came up with remarkably similar results. And so we combined the estimate from those two to get an overall estimate of how much BMI change you can expect for an hour reduction in television time. So let's walk through an example of what this looks like for the active recess intervention, which is one of the interventions that we have modeled. And this was published in a paper led by Angie Craddock and was published in Preventive Medicine. So for active recess, the question we're trying to look at is, if you have a school-level program to promote increased physical activity during existing recess time, is that a cost-effective way to reduce childhood obesity? So to implement active recess, it's an elementary school level program, and what you would need to do is say, okay, they already have recess, here's what we need to do to make it more active. We're going to put in playground markings, we're going to put in portable play equipment, and or we're going to have structured activities. So there are some different options that schools can use. And here is our strategy to health pathway. So for active recess, we ended up using 9 experimental studies that looked at changes in objectively measured physical activity during recess following strategy implementation. So we didn't have anything that went straight to BMI, but we did have several studies that looked at changes in objectively measured physical activity. We then converted that to a change in percent recess time spent in moderate to vigorous physical activity and summarized our estimates across these 9 studies to determine the most likely one, which was a 9.3% moderate to vigorous physical activity change. And then we also tried to look at the minimum and maximum so we could use that for the uncertainty estimates in our model. And we assumed that the average amount of recess time provided is 19.4 minutes. So we are then able to quantify the amount of extra moderate to vigorous physical activity time you might expect from an active recess intervention based on these kind of calculations and linking it through in the change. Then to get from that change in physical activity to a change in BMI, we used that Creamler et al. Estimate of that randomized controlled trial that had linked moderate to vigorous physical activity to BMI change. So they found that a 1 minute per day increase in moderate to vigorous physical activity is linked with a 0.02 decrease in BMI units in kilograms per meter squared. And this allows us to sort of multiply the change in moderate to vigorous physical activity that we expect from active recess by this estimate to get our estimated change in BMI.
Thank you for tuning into our presentation. You can learn more about the Choices Project, our research, and the community of practice by visiting our website at choicesproject.org.